And welcome everybody to the Daily Space Weather Show. We've got a lot of ground to cover today, and another coronal mass ejection headed toward Earth. We'll tell you all about it here at the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. I'm your host, Dan, a.k.a. Smash-O-Mash, just bringing you the most comprehensive daily space weather you'll find in the known universe, bringing your space and Earth weather together into one convenient and aesthetically epic video. We'll be doing a cosmic ray report, an update on the solar cycle. Lots of important stuff to cover in today's video. This is a 24-hour video from SDO showing 171 plus 94 angstroms. And here's a little closer view for you. The most recent earthly directed coronal mass ejection came from down in this area down here in the southwestern limb. We've seen a little bit of uptick in solar activity, despite a downtick in sunspot number. We'll get to that also here in a bit. First, another 24-hour video. Here's SDO 304 angstroms. The largest solar flare was only a C6.7? C6.76, I believe it was. And there you can see that CME coming out of the southwestern limb. Quite a significant coronal mass ejection. Some of that likely to strike Earth in about 3 days. Here you'll see that filament release, and there it goes. Some of it splashed back down. Some of it is headed in our direction. So that's what you want to see, right? We also have a new sunspot that just rose over here. One's also setting in the southwest. So to the northeast of our Earth scale in that image, a new sunspot rose. It's fairly modest so far. We do have some massive plasma filaments there turning into prominences toward the end of that video. And let's blast through lots more information, because there is lots more information to cover today. Here are sunspots for yesterday plus today. That is November 26th and 27th to date. Those groups mostly stable there. Again, one new group rose in the southeast. You'll be able to see it easier on the colorized magnetogram. Right down here, you see that magnetic field peeking over the southeastern limb. That will be a new sunspot in the next 24 hours. By the way, if you enjoy the content, don't forget to press the like button. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We provide additional content over there. Thanks to the Gold and Silver Smash Team members especially, there's even a bronze level there for all of you unable or unwilling to open your cobweb-encrusted wallet and send us a few bucks per month to produce the content. We've also got a Hemp Lucid shop, so check that out if you're shopping on hemplucid.com. Don't forget to enter the promo code SMASHOMASH10. Yes, SMASHOMASH10. It'll save you 10% on your checkout, even on your Delta 8s, or perhaps you're a THC-free person. SMASHOMASH10 will save you 10%. You can find a link below the video to our Hemp Lucid storefront, as well as on our homepage at smashomash.com. So perhaps support the channel that way. Perhaps support the channel and your health this way by picking up a 1-year supply of vitamin D3 for only $11.24, a savings of 25%. Amazon.com/shop/Smashomash is where to find our Amazon store. You can find lots of different supplements that I take. Vitamin D3, increasingly important as we get closer and closer to the winter solstice. We get less and less light, so there is more and more reason to supplement vitamin D3. Amazon.com/shop/Smashomash. Today's featured product is, from our merch shop, the Galactic Federation Special Forces motto, which is Universum Liberate, because if I could wave my magic wand, I'd set everybody free. Maybe that sounds too reckless to you, but that's just the way I feel, so I don't know. Whatever. Universum Liberate, the motto of the Galactic Federation Special Forces. Speak Latin, teach your friends and foes some Latin, and help support the Galactic Federation Special Forces interested in freedom and liberty on the galactic scale. Links below the video to the merch shop as well. as on the homepage at smashomash.com. So once again, welcome to the Neo Renaissance. Congratulations on Realize the channel exists. Press like, press subscribe, press share. Tell your friends and foes about the channel. Share on social media. Hit us up over there on X, the most active social media that we have. We're also regularly posting stuff on Instagram. And let's get to volcanoes. So first of all, Krakatoa has been exploding. Also, we've got a new island forming south of Japan, off the coast of Okinawa Beach. So Iwo Jima there, producing a new volcanic island. Good stuff. Luitolo also erupting, unknown volcanic ash plume there. Krakatoa producing a 7,000-foot ash plume as it explodes. Also, Rupahu, first Semaru, producing a 14,000-foot ash plume. Also Dakono, 9,000-foot ash plume as it explodes. Rupahu has been seeing some seismic activity. So, under the North Island of New Zealand, there is a volcanic lake there. There is some snow melt and things like that affecting things, but yeah. So, Rupahu there, some variations in the temperature of the lake, and some seismic activity beneath the lake. Popocatépetl exploding, flight level 210 over central Mexico. Santiaguito exploding, flight level 150 over Guatemala. Fuego also in that same nation, producing a 15,000-foot ash plume as it also explodes. Nevado del Ruiz in Colombia exploding, flight level 220. No volcanic ash observed from Revenador. Don't assume it's not erupting. Sabancaya is certainly erupting, producing a 25,000-foot ash plume. It's exploding, in fact. It's a flight level 250 over Peru. And there we'll scroll the warnings and the active volcanoes. Sweet! Next we'll go to earthquakes. And there was certainly a large earthquake. By the way, no eruptions at Iceland yet. There was certainly one large earthquake there in the past 90 days. And here is the largest quake of the past 24 hours. It just came in recently. A 6.6 off the coast of Papua New Guinea, just north of the island nation. There is the location of that 6.6 magnitude earthquake. That is a pretty big one. And that's the location of that quake. No tsunami watch, warning, advisory, or threat from that. And let's head down to the bottom of the list here to see the quakes of a 5 or greater magnitude over the past 24 hours. So these are the quakes of a 5 or greater magnitude. There was a 5.6 in the Indian Ocean there at the triple junction between the African, the Australian, and the Antarctican plates. That 5.6 at 2:34 this morning. Then Vanuatu had a 5.5 at 3:31 and a 5.4 at 3:56, and also a 5.2 at 4:17 this morning. South Sandwich Islands had a 5.0 at 5:13. Northern Mariana Islands had another 5 magnitude quake there out in the middle of nowhere. That was at 6:34 this morning. Then the Mogue Islands had a 5.0 at 10:04 this morning. Chile had a 5.0. Man, that's a lot of quakes. Chile's 5.0 magnitude quake was at 10:08 Universal Time this morning, so it was a busy morning for earthquake activity for sure. Some quakes on the coast of the U.S. there on the west coast, and there's that 6.5 downgraded from a 6.6. That 6.5 was at 21:46 Universal Time. And let's get back to space. There's certainly plenty to talk about there. Here's another 24-hour video featuring the house favorite wavelength 171 angstroms. Ah, yes, the Solar Dynamics Observatory. It is good times. And there's actually 2 separate events that happen here. There's one out of the southern hemisphere that was around midday, another one in the northern hemisphere that was much more recently, associated with a C6.76 class solar flare, which we will get to in a moment. Once again, this new sunspot actually recently rose down here in the southeast, and we kept that pretty far south there so that we could show that giant plasma filament that looks like it's anchored sort of northeast of that sunspot. So a huge arcing filament of plasma there hanging out over the top of that sunspot. Could become quite unstable, folks. Quite unstable indeed. And let's talk some more stats. The 10.77 meter radial flux now at 187 solar flux units. There is our little graphic for you. 10.7 is at 187. So that's the past year approximately. The black line is the radio flux. The red line is the sunspot number. Space Weather Enthusiast dashboard here, not forecasting any geomagnetic storm conditions. And when we do tomorrow's space weather video, it will be, because there is another CME headed this way. So to see our previous coronal mass ejection forecasts, make sure you watch our previous videos. This one from today is only going to talk about the events that have happened in the past 24 hours. That's the luxury of doing daily space weather content. And here is NOAA's Enlil spiral. So let's actually bring that into the full screen type view here. There we go. And it looks like NOAA's already modeled it. It's just not on the Space Weather Enthusiast dashboard page yet because that only shows 3 days. So there you go. Sometime around early in the day on the 30th of November, expecting another CME impact. And it looks like it is a little bit off to the west towards stereo A. It's mainly going to miss to the south. So there you can see in that model there, that CME brushing past, not a direct hit, but some ejecta likely to hit Earth. If it does cause geomagnetic storm conditions, they should be pretty minor. Here's NASA's Enlil spiral. And this is not yet modeled yet by NASA. Perhaps in tomorrow's daily space weather video it will show up there. That is some old stuff. And let's move on to Earth's magnetic moment from space. So here are the past 4 hours of croissant Earth. The planet which people think is shaped like a sphere, but it's actually shaped like the French breakfast pastry. And of course, this is part of the reason why we say that all the time. The Croissant Earth Society. You know, all the funniest jokes are the ones that are based on truth, right? So those are the past 4 hours of magnetohydrodynamic pressure from planet Earth. Next, Earth's magnetic moment from the ground. Also the past 4 hours. So that's what's been going on. Geomagnetically calm conditions. Geospace delta B refers to changes to Earth's B field. And the units of magnetic flux density are nanotesla. KP index currently at 1.33. I think it's the same point it was at on yesterday's daily space weather video. 1.33 geomagnetically calm conditions. And here come the solar wind data. So first the ACE. The ACE showing quite diffuse solar wind here, a little bit above average. Let's switch to the Discover. It's a little bit better signal there. Discover showing 5.6 protons per cubic centimeter for the solar wind density, solar wind velocity here, just under 460 kilometers per second. GOES magnetometers are smooth, as you may have expected during this period of geomagnetic calm conditions. Next, our top view ecliptic plane field plot. And has Earth moved into a South Pole current sheet? Indeed it has. So when we stop this at the latest image, you'll see just recently in the past few hours, Earth has moved into a South Pole-oriented sector. And the South Pole is definitely going to be in the news because of solar polar field reversals. We'll get to it. First, our line-of-sight field plot. Here the sun's B field is depicted in blue, polar fields in red and green for south and north respectively, the photosphere magnetism depicted in grayscale, which brings us to our line-of-sight ecliptic plane field plot. So there is more heliospheric magnetism for you folks. And that brings us to coronal holes. There's our coronal hole line-of-sight plot. And not surprisingly, we've got South Pole-oriented coronal holes rotating into the Earth's strike zone. Anyway, there's the latest image. South Pole coronal holes in the northeast, North Pole coronal holes in the southwest. So it's kind of like this right now. These are north, and these are south. So that's the current situation. Let's get to sunspots. I guess they're kind of important, right? People are all concerned about sunspots. Oh no, are there sunspots? Are there not enough sunspots? I'm very spooked. Are there too many? Are there not enough? There's got to be just the right number of sunspots, folks. Otherwise, people are spooked. Spooked, I tell you. And by the way, if you enjoy the content, press the like button, or else there will be repercussions, possibly even for your soul. Seriously, press the like button. Help us out with the algorithm. If you're unable or unwilling to open your cobweb-encrusted wallet, let some moths free. And, what's that? You refuse? Okay, press the like button. We'll just wait. No, that's okay. You take your time. Take your freaking time to press the like button, folks. That's okay. We got all day. We don't have all kinds of other things to cover, like cosmic rays and the solar cycle progression or anything. No, you take your time. Folks, you're being held up right now by those slackers who refuse to press the like button. Jeez. Sorry to trouble you with such difficult tasks. By the way, if you want to get involved in our Ask a Particle Physicist segment, we're about to rename it Ask a Physicist segment. But anyway, if you want to get involved in that, we've built a forum thread about it at smashomash.com/forum. If you come down to the General Science Forum, right there you'll find a pinned thread, Ask a Particle Physicist segment. That is where to submit questions to Ask to a Particle Physicist, and let's talk about solar cycles. So just yesterday, the solar cycle graph was updated here at solon.info, so let's take a gander at that. Check it out. The South Pole is just about to reverse. It's very, very close to the zero line. The North Pole has already reversed, which is what this green line indicates. So, but it has snapped back across to the other side again. So it's reversed and then unreversed. Meanwhile, the South Pole current sheet, the South polar field is certainly looking like it is very, very close to the zero line. I mean, let's zoom in. I'll zoom way in on that just to show you how close that is to the zero line. When it crosses the zero line, that represents the South polar field reversal. So right here you can see when it happened during solar cycle 24. It's just about to happen. It could be days away, although it could suddenly change direction there. So looks like it's just about to reverse. And the North Polar field has got to sort of re-reverse because it's now gone back into positive territory. So that's the current situation for the solar cycle. South solar polar field just about to reverse. And of course, we can't know when solar maximum is until after it has already passed. So, but it is on the way, as those polar field reversal processes are crucial to the sunspot cycle. Now you can see that during solar cycle 23, the South polar field reversed first. Cycle 24, the North polar field reversed first. There's that green line. The red line there is the reversal of the South polar field. Looks like a red line is about to show up there on that graph, and let's get the sunspots. So sunspot number is now down to, let's see, that's at about 168 it looks like. There you go. There's the sunspot number according to Rob, the Royal Observatory of Belgium. And let's take a brief look at sunspots here. We'll zoom in a bit on the equator. And not a lot of changes happening there. Again, at least one group setting in the west and one group rising in the east. I think we'll have a continued dip in sunspot number tomorrow unless new sunspots form, as it looks like more sunspots have set than have risen to replace them. Next, flare probability and scoreboard. And you can see a very high likelihood of even X-class solar flares from this group down here, 3500. Sunspot 3500 is the most magnetically complex, followed by this massive sunspot group up here. So two likely spots to see M-class flares, and only one likely spot to see an X-class flare. That's sunspot 3500. That's checking off the boxes for magnetic shear. And let's get to solar energetic particles and flares. So no spikes in the proton flux, therefore no solar energetic particle events. And again, the largest flare of the past 24 hours was just a few hours ago there, a C6.76 class solar flare. Let's take a look at our flare wavelength. There you go. That is. Now keep in mind that's not actually X-rays, that is extreme ultraviolet, but 94 and 131 angstroms are specifically formulated to view solar flares in that they have a higher temporal resolution. They take more images per minute than the other wavelengths, 94 and 131 angstroms. That's why you see so many images of solar flares in these wavelengths. They have the best capability to capture the peak flux moments. Again, keep in mind it is extreme ultraviolet light, not actually X-rays, which is what a solar flare is. And before we continue on, let's get to our cosmic ray report. So we haven't done a cosmic ray report for a while. It's time to do one, as we are seeing the lowest levels of cosmic ray flux for nearly 20 years. So for everybody who keeps saying, oh, the energy from space is increasing, it's increasing, lowest cosmic ray flux since 2004. So there's the Opacity Neutron Monitor, which is down significantly over the past 30 days. Barentsburg, also down significantly over the past 30 days. Lowest levels there for the entire solar cycle. Next, we'll go farther south to Athens, Greece. Athens, Greece also exhibiting a significant downtick in cosmic ray flux over the past 30 days. Mexico City, by the way, this right here is what we call a 4-bush reduction, a 4-bush decrease. Right there, that decrease in cosmic ray flux was a worldwide decrease associated with the most recent geomagnetic storm conditions. Significant downtick at Mexico City in cosmic ray flux. Energy from space is decreasing. And please don't listen to people who say energy from space. That's not science terminology. That's what people who are aren't versed in science would say. Energy from space. Okay, cosmic ray flux is a real thing. Energy from space is a term that is so vague that it's meaningless. Next, going way back up north, since we went to Mexico City, here's Oulu, Finland. Oulu, Finland, a major decrease in cosmic ray flux over the past 30 days. And once again, I would show this. Lowest levels of cosmic rays since 2004. And that is on a global scale. You can go compare other monitors. One of the places to do that would be at Athens. You can bring up all kinds of monitors, all on the same graph at Athens. Anyway, here's DOMB Antarctica, which is actually a lot flatter over the past 30 days. And there's DOMC Antarctica, a big decrease over the past 30 days. And of course, the 4-bush decrease shown there. So that's interesting there. DOMB Antarctica is an outlier. All the rest of the cosmic ray monitors showing a significant downtick for the past 30 days. Next, we'll get to a star chart. This is what's going on over our head. That's Lehigh Valley, Pennsylvania's star chart. We've got Saturn, we've got Jupiter, and we've got the moon there approaching the full phase. Here's your solar system forecast. This is where things are today from theplanetstoday.com. Here's where they'll be in 1 week. There you go. That is December 4th. And it looks like full moon will fall on tonight. Yeah, tonight. Full moon tonight. Next, our astronomy photo of the day. And this is the Ratfish Nebula. It's not the Ratfish Nebula. It's the Eagle Ray Nebula. I don't know how they get an eagle ray out of that. They're extremely imaginative when naming nebulae. There you go. That's the Eagle Ray Nebula. And that dust in there, that dust lane, those type of dust lanes typically consist of carbon, silicon, and oxygen, frequently with frozen carbon monoxide and nitrogen. The molecular cloud of LBN 86, otherwise known as the Eagle Ray Nebula. There's some more close-up spectacular imagery for you, courtesy of Vikas Chander. Nice shooting there, Vikas Chander. Vikas Chander. The Eagle Ray Nebula, the astronomy photo of the day at apod.nasa.gov. Next, CMEs. And like I said, there are some more headed this way, at least one more. Here are 105 frames from yesterday. See yesterday's daily space weather video if you want to see the CME forecasts. So that's yesterday. And here are today's frames, another 93 frames, and you'll see at least 2 CMEs popping off today. One kind of early this morning at about 8 o'clock Universal Time. That's the one that has earthly directed components. Right there. And then a second one looking like it's coming out of the east, but I think that's another earthly directed CME. So that'll be another one likely to arrive sometime like late in the day on the 30th, maybe on December 1st. It all depends on speed, and it's too early to tell. Let's look at some more coronagraphs. Here are the SOHO coronagraphs. And it looks like that most recent CME might be a full halo there. It did come out of the northern hemisphere, I think. Let's get these a little closer to synchronized here. We'll look at stereo A also. Here's where stereo A is located. And there we go. We've got the raw coronagraph on the left and difference imagery on the right. We'll let those play through the full 90 frame run. So there's the first event out of the southern hemisphere. And it looks like the more recent ones are not going to show up there because there's missing data. So let's move to our custom coronagraphs. Here's a 24-hour video showing SDO. That's 193 angstroms in the center. Soho Lasco C2 in blue, Soho Lasco C3 in blue, and C2 in red. A little bit of ejecta headed in Earth's direction. Not likely to cause a major geomagnetic storm. Probably something to max out at KP 5.66, I would say. Again, most of that ejecta likely to miss. But then there's a second event from up here. And this one might be a full halo here, so it's a little bit too early to tell. I suspect that's a second CME headed toward Earth, likely to arrive later in the day on the 30th or early in the day on December 1st. So I suspect that is quite a perfectly earthly directed one, based on the way it looks on that preliminary data. Again, it came from right up here. And oftentimes, perfectly earthly directed CMEs are the stealthiest ones because they stay behind the coronagraph for an extended period of time. So a likely pair of CMEs now headed in Earth's direction, likely to start arriving on November 30th. Anyway, here's a closer view. We've got the equatorial zoom for you. Those same awesome wavelengths. 304 plus 193 angstroms. Ionized helium and ionized iron, respectively. That is some hot gas. Next, moving on to, what are we moving on to? Something. Plasma filaments are next. So there's a situation. I'm back. There's a situation at Big Bear. And this filament right here is the one that has now ejected, and lots of plasma filaments still litter the Earth-facing portion of the solar disk. Here's the grayscale imagery. Yes, good stuff. And don't forget to follow us over on Twitter. If you do the social media, you'll get shares that you won't see anyplace else. Perhaps the shadow banned capital of the world, Twitter, the place where people idiotically think that censorship has been fixed on the internet because they're in the Elon Musk cult, which is just about as pathetic as every other cult out there. Censorship continues over on the pathetic and putrid social media and quote platform X, known by sane people as Twitter, who understand what a brand is. Anyway, before we get to bonus features, we'll show the last couple of hours from the GOES 18. So there's the GOES 18 ionized helium. Looks like this crown prominence down here is becoming a CME as we create the video. Also, eyes on this filament over here. It's looking like it's becoming unstable. It is anchored near a sunspot after all. And let's move to bonus features. First, satellite charging hazards. We ain't got none. It's smooth sailing. Neither surface nor internal charging hazards are currently in effect for satellites. GOES electron flux here coming up off the floor. We are expecting an uptick in the electron flux in the coming days. And there is the 1-year graph of the electron flux. To contextualize that, there's the 3 days, and there's the 1 year. Here's the forecast. NOAA is agreeing that they're expecting an uptick there. No argument from me there. That's the forecast for relativistic electrons. We'll also show the layer where it's measured. You got to show the layer where it's measured. The F layer. That's what this red F means. It's about at this altitude. And here is the vibrational frequency. So the gas up there is very diffuse. It does vibrate quite a lot. It is the bridge between Earth and space, but from a human's perspective, that's space. There is nothing resembling what you would call air at 300 kilometers of altitude. And we have a very normal-looking ionosphere. So if you were looking for the end of civilization to be foretold by this ionosphere data, sorry, not there. Nothing scary about it in the slightest. Here's the anomaly in megahertz from a 30-day median, and it looks absolutely normal. South Atlantic anomaly is exactly where you'd expect it, right over the South American continent. Central African anomaly, right in the same place you'd expect it. Southeast Asian anomaly, right where you'd expect it. In other words, absolutely nothing scary whatsoever in the ionosphere data, or really anything else. If you're spooked of space, you may be watching the wrong channel. Anyway, there's the latest image, 2315 Universal Time Ionogram, 2315 Universal Time Anomalygram. We also show the Global Ionosphere Nowcast, otherwise known as the WAM, the whole atmosphere model, depicting total electron content on the left, maximum usable radio frequency on the right. That's what's been going on. We'll also show total electron content by itself. There you go. That is free electrons from about 12,500 miles of altitude down to your handset level. Free electrons cause signal refraction, aka GPS errors. And here's the anomaly in megahertz. That's not megahertz. That's the anomaly in electron content over North America from the 10-day average. Yeah, that's it. Anomaly in electron counts. It's literally a count of free electrons. That's what's going on. We are seeing some high electron count anomalies off the coast of Baja California as well as in northwestern Canada. So that's the scenario there. Last but not least, the latest intensitygram and the latest magnetogram. What's up with that? Is that a sunspot forming way up there? Not yet. A little bit of magnetic action happening up there, though. I see a little bit of organization happening there. Anyway, here's a brief look at this new sunspot. It is pretty modest. It looks like it's only alpha class. Anyway, here's the full disk. Once again, the most likely places to see large flares would be there for an M class, and here for an M or even an X class event. And let's get to meteorology, starting with mean sea level pressure. So this is what we're starting out with. That is the world's pressure map. Mean sea level pressure and surface winds. Huge anticyclone here over the northern Atlantic. The world's lowest pressure is down here in the Southern Ocean. Only 954 hectopascals. Those, my friends, are some stormy seas. Anyway, let's switch to our regularly scheduled meteorology segment, starting out with the jet streams today. These are the jet streams of the eastern world. Actually, those are surface winds. Here are the jet streams of the east, jet streams of the central world, surface winds of the central world, surface winds of the west, windy times in the Great Lakes. Make for very dangerous sailing. Did you know the Great Lakes Triangle is way more dangerous, statistically speaking, than the Bermuda Triangle, which really isn't that dangerous? Here are the jet streams of the western world. Significant jet stream, convergence happening here over the U.S., the eastern portion of the country there. And let's move on to clouds and fog. There's our shortwave radiation map for the Americas. Not too bad as clouds rapidly form after sunset once again in South America. Looks like a normal thing going on down there. I got to do more South American weather. It's pretty exciting. And next, clouds and fog. We're just going to show this area right here as we have a low kind of in Canada there north of the Great Lakes. You can see a bit of a counterclockwise rotation happening there. That's shortwave radiation from the NASA GOES Interactive Weather Satellite Suite. It shows clouds and fog even at nighttime. And here's our precipitation type as snow starts to fall in Pennsylvania, also West Virginia, and all around the Great Lakes there. Most of Michigan getting snow here at the moment, parts of New York, New England, etc. That's precipitation type from windy.com. And here comes some forecasts, but first, our weather.gov map. So there is the key. We've got some freeze watches in parts of Florida, Georgia, South Carolina, and even Alabama. Here comes some forecasts, starting out with the GFS pressure and precipitation. There's the GFS pressure and precipitation forecast for the next 72 hours. Next, the GFS total accumulated snow depth change in inches. Same model, the GFS 72-hour. Next, temperature anomaly forecast in degrees Celsius. Same model and same period, 72-hour GFS. And last but not least, the jet stream forecast. We haven't shown it for a few days, so here's what's really in charge of your weather. The force that's responsible for moving most weather from west to east is the jet stream. There it is, 250 millibar wind speed forecast, the GFS 72-hour model. Getting toward the end of our video here. Here is lightning for the past about 10 hours. Here is lightning for the past hour. A real-time lightning map from lightningmaps.org. Only 18 strikes per minute. It's a pretty low lightning environment right now, folks. Oh my God, there's not enough lightning. Oh no, Zeus must be on vacation. We'll close out with U.S. Doppler radar, clouds and fog, and water vapor, as we do, bringing the weather from the sun all the way down to the lower 48. So there you go. Snow falling in the northeast U.S. Satellite-based clouds and fog map. Satellite-based water vapor map. Moisture moving into Montana. Here's your recap. Ground-based Doppler radar systems. Space-based shortwave radiation showing clouds and fog. Space-based water vapor showing all of it, including the dry portions. And here's me signing off. It's time to get back to the bunker, because I came out of the bunker just to make this video, folks. So, you're welcome. Anyway, I'm headed back to the bunker again. I'm really spooked of space from nonsense I took in.